Welcome to the computer industry's groundbreaking era. The time when computer engineers were the only ones who created software is long past. Today, software creation crosses boundaries and integrates with AI supercomputers. We are about to enter the world of generative AI as we stand at the edge of accelerated computing. As we begin the beautiful path of releasing the H100 in high-volume production, our excitement knows no bounds. Get ready for an evolutionary change that will impact every imaginable industry. I'd like to present you to a computer system board that contains an amazing 35,000 components. I'm in awe of this technical marvel, which has been fitted with 8 Hopper GPUs. It weighs a substantial 60 to 65 pounds, and due to the intense pressure involved, robots are needed for both lifting and precision placement. This computer, which costs 200 grand, will completely replace rooms full of other devices. Introducing the H100, the priciest computer ever made. Surprisingly, you save more the more you gain. The groundbreaking transformer engine, which provides unmatched performance, is displayed in its computer tray. The end of exponential CPU expansion and the emergence of deep learning, which fuels rapid computing and generative AI, are two major shifts the computer industry is currently going through. Both opportunities and difficulties are presented by this revolutionary change. In barely 3 decades, accelerated computing has revolutionized technology, the foundation of generative AI. Massive language models are strengthened. When training a large language model, 11 gigawatt-hours of CPU power are needed, but just 48 GPU servers. Although GPU servers might be expensive, the data center is increasing the main location for computing. Our primary goal is to construct incredibly efficient data centers. Scientific fields, businesses, and data processing all rely on accelerated computing, which provides flexible software deployment options from the cloud to edge computing. With the ongoing HGX Omniverse and dedicated cloud variants, the GPU landscape has grown. The huge demand for NVIDIA GPUs is training data centers and the clouds. Since GPUs are so versatile, rapid computing and generative AI have now reached the tipping point. Through GPU connectivity, NVIDIA AI, the only AI operating system in the world, revolutionizes deep learning process. The computer business is transformed by this partnership between engineers and AI supercomputers, propelling innovations and changing the environment. The computer industry is transitioning towards AI factories, where businesses use faster computing and AI to become intelligence producers. In just 5 years, we've made incredible strides, speeding up computer graphics by 1,000 times. Future computers will be 1 million times quicker, changing the way artificial intelligence is used across industries. Imagine the revolutionary impact a computer with 1 million times speed could have on modern computing. In this new computing era, with the help of huge language models and computers that can grasp the user's wants, programming becomes simple and everyone can become a programmer. AI bridges the digital gap and boosts productivity across platforms including Windows, browsers, PowerPoint, and Word. It also improves every current program. Because of all the user-friendliness of the current computing era, growth and adaptation are accelerating quickly, without the requirement for purely new applications. Enter the new era of computing, which has a significant impact on every industry. Introducing Grasshopper, a cutting-edge processor with remarkable features and 200 billion transistors. As the first accelerated computing processor in the world, with a coherent memory capacity of around 600 gigabytes. It established a new benchmark. The CPU and GPU no longer need to copy data amongst one another, thanks to this fast memory. Grasshopper is a full-fledged computer that contains all necessary parts, not just a single chip. We present the Grasshopper Superchip, a power-efficient processor designed for applications in resilient data centers. We obtain an extra flops-level performance by combining numerous Grasshopper pods. Each one has 8 linked processors. which makes transformative computational skills possible. Take a look at the groundbreaking Grasshopper AI supercomputer. It displays the enormous power of a single GPU and weighs 40,000 pounds, with 2,000 fans and 150 miles of fiber optic wire. Its use will be pioneered by Google Cloud, Meta, and Microsoft, pushing the boundaries of AI research. Introducing the DGX GH200, a massive GPU that boosts a number of AI data centers throughout the world. Over the next 10 years, we want to convert current data centers into facilities that can accelerate and generate AI, enabling a range of applications in scientific computing, data processing, cloud services, videos, and graphics. Introducing the breakthrough open modular service architecture for accelerated computing, the NVIDIA MGX. It offers increased density and specialized capabilities and is tailored for enterprise, edge, and a variety of applications. This innovative design accommodates particular needs and makes the implementation of accelerated computing systems simple. Multiple servers are combined into one using accelerated computers, saving money and physical space. Our standardized design supports upcoming GPU, CPU, and DPU generations, maximizing market preparedness and protecting investment. This modular approach takes care of various data center requirements. Discover the potent features of the Omniverse OVX server. The Grace Omniverse server, comprising the L40S, BF3, Bluefield 3, and CX7, is now available. Discover the liquid-cooled server, Hopper Unveiling, Dense Grass Superchip, and Grass Cloud Graphics server. Grace uses 580 watts instead of the typical 900, considerably decreasing power usage while maintaining performance. It doubles performance while using the same amount of electricity, taking AI into new realms. As the center of computer operation, data centers are essential to today's society. Data centers can be divided into two categories: those built for closely coupled AI supercomputing tasks with high throughput, and those built for a variety of workload with minimal CPU and GPU connectivity. Hyperscale cloud infrastructure, supercomputing facilities, and AI supercomputers are separate things. The ability of Etherlink to link globally is essential for the development of the Internet. While beyond a 95% threshold, supercomputing data centers prioritize accuracy and efficiency, necessitating certain interconnections. The minimum workload throughput of 50% is worth $500 million. Every GPU in high-performance computing must finish its duty before further work can be done. It is essential to introduce a new type Ethernet that can accommodate AI workloads in any data center, while also being backwards compatible. Adaptive routing is one method which dynamically diverts heavy traffic to less crowded ports. This makes it possible for the GPU to receive data directly from Bluefield 3 without the CPU being involved. Controlling congestion is essential for managing network performances, avoiding problems with data transfer, and increased throughput. Congestion control implementations greatly improves Ethernet performance. The enterprise-grade and secure CPU software stack satisfies stringent security, administration, and support standards. 4,000+ software packages are used in accelerated computing for data processing, training, optimization, and interference. Similar to Red Hat for Linux, NVIDIA AI Enterprise offers an enterprise-grade and secure software stack while streamlining management. This groundbreaking innovation increases the potential of accelerated computing for commercial use, providing advantages for businesses. The advantages of accelerated computing in the cloud are remarkable, at roughly 5% of the cost of CPU processing. Image processing using NVIDIA AI Enterprise on a GPU delivers a stunning throughput of 31.8 images per minute. Major cloud computing platforms like AWS, Google Cloud, Microsoft Azure, and Oracle Cloud currently support this integration. By meeting the special requirements of AI workload, it has completely transformed the sector. Accelerated computing and generative AI are two important industry shifts that are brought into action by our affiliation with NVIDIA AI Enterprise. First off, This type of computing does not correspond to conventional general-purpose computing. Each domain-specific full-stack, data center-scale solution is how it functions. Across industries, having the right software stack is essential for maximizing equipment utilization. Secondly, we have a fully operation HGX H100 engine for generative AI. It serves as the framework for AI factories, and Grasshopper, an engine created for the era of generative AI, further increasing its scalability. We present the largest GPU in the world, the GGX GH200, utilizing Grasshopper and NVILink. Our objective is to broaden generative AI and fast computing in numerous ways. We turn any cloud data center into an AI data center with Spectrum X. MGX modular accelerated computing devices offer secure deployment of cutting-edge generative AI models in any cloud environment by working with the Taiwanese ecosystem.